So anytime we have a straight line, hence that we use the line of best fit. So I'm always going to allude to the assignment you just did for me, okay? Anytime you have a whole bunch of dots in a scatter plot, the reason why we draw a line of best fit and we only talk about the line of best fit is because it's a straight line. It's so much nicer to talk about trends and patterns with a linear relationship instead of trying to make sense of a whole bunch of random dots. So I was talking to Jesse the other time, when you have a whole bunch of dots, you might be using that up until grade 8. And that, yes, is a scatter plot. And you can talk about these data points individually. But these data points, whatever all of these points are supposed to give you information about a trend. If you keep on using specific numbers that you get in an experiment, you are not going to get you often will make mistakes, or you may not get the kind of trend you're looking for. The reason why we do so many different trials is so that we can get as many dots as possible so that we can draw the most accurate straight line possible. Now's the time for me to say, if you answered any questions based on just the dots for your Barbie bungee, you might not get the exact answer I am looking for. All of the answers you give me should be discussed based on your straight line. Now, your Barbie bungee also got you to do something like this. I'm going to pull someone's data. I think someone's had a 33x and started with like a 30 or something like that in their data, right? And you're able to identify 33 by calculating your M from the line. You're able to calculate the 30 by just following the line to where the y-axis is. These two numbers, or these two letters, M and B, I am going to call it M for slope, which we talked about last class. And instead of the initial value, listen carefully, instead of initial value, I am calling it the y-intercept. Why is that an appropriate name? You need to identify it so you don't get confused. I don't want you memorizing the word y-intercept. I need it to make sense to you. Why does it make sense that we call this B value the y-intercept? Yes? Yes, that's it, right? Mathematicians, not as simplistic as possible because we have other things to think about. This value right here, this point, is called the y-intercept because that line cuts through the y-axis at that point. In other words, if I say that the y-intercept here is a 1, it means the coordinate is x equals 0, y equals 1. They are one and the same. Y-intercept of 1 is the same as point of 0, 1. They are one and the same. Let's move on. Why does this help me? How does it make my life more efficient? And how do I talk math using this data? Take a look. If you were given a linear equation, you can identify the slope and the y-intercept immediately based on where the x value is. Pop quiz. How do you know it's linear? No. Look at the equation. What of the equation tells you that it's linear? And all of them. 3? Man after my own heart. All the exponents have a 1. Do you remember that lesson? I don't know. If you had x to the power of 2, that is not a straight line. It's something fancy that you'll see in grade 10. The exponent has to be 1. That's how in my head, I know I'm dealing with a straight line. Here we go. When given a straight line, always compare the equation you have with y equals mx plus b, the generic template equation. The 5 and the -7 tell you something about the slope. 5, which is multiplying with x, is the slope. Or of course, please remember that 5 is the same as 5 over 1. So my rise is a 5, my run is a 1. Y-intercept, it's a -7. Or please remember that the point is 0, -7. They are interchangeable. Yes, Abby. It's the number that is multiplying with x. It's always going. Oh, the equation for this question, the equation gave me a 5 multiplying with x, so I know that's an n. The y-intercept. Oh, the x? It's not given. X and y are left alone because when we're using the equation, when we want to solve something, they will give you an x and you have to find the y, or they will give you the y and you have to find the x. The other two numbers have to be there. Oh, well, remember, what did I say the y-intercept is? Y-intercept is a point that's on this y-axis, correct? Yeah. And if it's on this y-axis, the x value is always going to be a 0. Oh, okay. So if you say y-intercept, you automatically know the x is going to be 0. No. So the initial value is the y-intercept. Correct. If you think about every graph you drew, wasn't it always on the y-axis? Every initial value, it was on the y line or the y-axis. So there's the connection. Let's continue. Y equals 3 over 4x plus 2. Slope is rise over run. Okay. And the y-intercept is a positive 2, or you can say the y-intercept is 0, 2 as a coordinate. Slope, y equals -1 over 3x plus, minus 3. The slope is a -1 over 3, so my rise could be a negative, my run is a positive. My y-intercept is -3, or you can say 0, -3 is my coordinate. Yes? So how are you actually getting the y-intercept? Right here. That number is always the y-intercept. It's the b value, right? Case in point, always know that number, right? We called it the initial value up to now. Initial value. Now I'm going to call it the y-intercept. Any questions so far? Well, you might have questions. Do these three. Go ahead. Judging from the equation I give you, you should be able to immediately figure out the slope and immediately figure out the y-intercept. Go. I'll give you, I'm going to say 1 minute. I think that's more than enough. All right, very quickly, if you did this right, the slope is -3, the y-intercept is -2. The slope is 5 over 3, the y-intercept is 9. The slope is -4 over 7, the y-intercept is -1. Okay? Not. Can you do the reverse? I think you can. I'll do the first 3 very quickly to confirm that you are on the right track. If I have a slope of 3, remember, the slope of 3 means rise over run would equal 3 over 1. Okay? A y-intercept of 6 means that I have the point 0, 6 on the graph. Putting those two together, I know for a fact that y equals 3x plus 6. This one, my m, my slope is 1 over 2. My y-intercept, my b is -5. So my equation is half x minus 5. Same thing. My slope or my rate of change is -3 over 5. My y-intercept, my b is -1 over 4. Don't be turned off by the fraction. It's still the same thing. And it looks like that. See if you can follow these patterns and create an equation if you already know slope and if you already know y-intercept. I'll give you another minute. All right, let's continue. It looks good. Everyone seems to be on pace. And if not, then that's okay. You're still getting the hang of it. Proper equation, the slope is -3. It's multiplying with the x. The y-intercept is a 2. Following this same pattern, we have 0.5. And y is equal to -2 over 5x minus 6. Here's the thing. You can still get perfect just from copying the pattern. Now I need to make sure you understand what each of these numbers mean. So I'd like you to connect each of these numbers with a graph itself. I'll do the first one and I'd like you to try the others by yourself. Identify the y-intercept. In other words, tell me what the b value is. My graph, the y-intercept, correct. I noticed that the point 0.03 is on the graph. So my b value is a +3. Next, I need to calculate slope. Well, the question doesn't give me the number itself, but it does give me 2 points. I could use any 2 points. I could use 0.3 as well, but might as well use letter C and letter D.
How do you know which one to subtract?
It doesn't matter.
You do 1 minus 5, 5 minus 2.
You could, which one did you do? Which one, did you use C first or D first? It doesn't matter. So how about we just use D first? The y is on the top, the x is on the bottom. Minus, minus. Y is on the top, x is on the bottom. So 1 minus 5, -4. 4 minus -4 is a +8. It is -1 over 2. My m, -1 over 2. My b, a 3. Put that together, and all of a sudden, wow, you are doing math. You are writing relationships between x and y. Yes, and you know what this relationship is. You know that -1 over 2 is how we're moving along the line. You know that 3 is where we are starting on the y-axis. Everyone, like, you got to understand. This is math. Okay? Math is not memorization. Math is not, following rules you don't understand and trying to just abide and not make any mistakes. Math is trying to communicate a relationship that you see. It's trying to communicate something. So I hope you're seeing a different side of the math from what you have previously seen before. Let's continue. I'm gonna help you with the slope, but I think you're able to identify what the y-intercept is. Okay. M, again, this time, Angus, I'm gonna use B first because it's on the left side, and then I'll use A after, just because my y value is on top, my x is on the bottom, minus, minus. Y is on the top, x is on the bottom. That's -4 divided by a -4. That is just a +1. So what's my y? What's my equation? I think you can figure it out. Try to do parts B and C, oops, on your own. Oh no, I erased everything. Sorry. Okay. No. There's work. Yes, question? Okay, so let me finish this and see if it answers your question. So just to recap, for this one, my y-intercept is, let's do it in blue, right here. That's a 2. My slope, based on my calculation, I believe it was a, sorry, positive 1. So my equation is 1x plus a 2. Plus 1. If I remember correctly, before I erased everything, I actually did a slope calculation. So I'll do it one more time with you. In fact, you know what? Let me do the next one, and I think you'll be able to see what I'm looking for. Next, for part C, my y-intercept is right there. It is a 0, -4. It's on the y-axis. So my b value is going to be -4. That's my initial value based on our graphing and our RB bunching. My slope, I don't have the number itself, but I do have this point, and I do have the point -4, 0. If you remember, the x value comes first, the y value comes second. So my x value is -4, my up down y value is a 0. With these 2 points, I am going to calculate slope by y on top, x on the bottom, minus, y on top, x on the bottom. You get -4 minus 0, -4. 0 minus a -4, +4. That's a -4. So my equation is -1x minus. I will wait, and Andrew, you let me know if the question has not been answered yet. Okay. Give it a minute. Some of you are starting to probably get the hang of the pattern between these 2 numbers, like as if it was like a conveyor belt of instructions, and you're starting to get really just muscle memory into it. You'll probably be able to do the next page on your own, but I will work through example 1 and 2 and then assign just the back of that page as homework. You leave the last 2 pages alone. Okay, question? Yeah, did you do like 4s on top and 0s on the bottom or something? Yeah, it's a common mistake. That's why I said previously in other classes, you have to be careful of your carelessness, right? I know you know how to do this. It's just if you make the slightest mistake, just because you're like, oh, I know this, and you sort of, let your guard down, you might mix up small things like that and it gets a completely different number, okay? Last one I want to do before I let you go. This is all I'm asking us to do in class, and this is what I'd like you to try at home. Graphing linear equations. Let me do this, and let me show you how I want this done. My last question? Yeah, go ahead. All right, I give you a graph, and yes, it was intentional that I give you a fraction, because I want you to know that it's not a big deal. Take a look. Looking at this equation, what is the y-intercept, aka what's the b value? 2. So on the graph, being a 2, you know that I'm going to have the point 0, 2. Can you find it and give a big circle on that? 0, 2. It means my x value is a 0 and my y value is a 2. It's right here. That's a little bit big. Okay, next, look at the slope to get a clue of how we are going to move from there. Okay, what does that mean? Remember that the slope is rise over run. So in this case, the rise is +1 and the run is +3. What does that mean? It means every time I go up by 1, it's because I went to the right by 3. So from here, up 1, right 3. Up 1, right 3. And up 1, right 3, but I'm not going to write that. Pardon?
Also, we start at the 2, right?
Correct. We know that this is part of the line, so why not start there? That's why we call it the initial value, the starting value. On the flip side, if you want to add this somewhere in your notes, I welcome it. Remember that m, if it's 1/3, it could very well mean that I had a -1 over a -3. If that's the case, what is my rise if I say it's a -1? What direction am I moving? Liam? If my rise is a -1, yeah, instead of up, it's going down. So down by 1. And if it's a -3 as my run, left. So I could also just as easily go down by 1 and 3 to the left. Down by 1 and 3 to the left. And guess what? I know I'm doing it right because it doesn't betray my trend. Right? It still fits that pattern. So up 1, right 1, down 1, left, sorry, up 1, right 3, down 1, right 3, left 3, geez. It's the same thing. Using a ruler, draw the line. Remember to add arrows at the end because it goes on forever. Also remember to label your graph. So I think it was Sloan that was doing it. He was thinking about it in an interesting way. He was asking, okay, now that I have an equation, am I supposed to plug in x equals 1 and solve for y? And then plug in x equals 2 and then solve for y? And then plug in x equals 3 and then solve for y and get every single one of these dots? You could, but I believe that is more work than you need to do. All right. Second example. On the same grid, graph the following lines. Y equals -2x plus 6. So let me label this as y equals 1/3x plus 2. On the same grid, I know that my slope is going to be -2, or it's actually equal to -2/1. Or I can say it's equal to 2/-1. You'll see why I'm being a little annoying like this. My B value is a 6. In red, let's draw it. I'll give you a minute. My slope is this. My y-intercept is this. Can you draw it on your own? I'll give you a minute. Give it an honest attempt. So this is my last bit for today before we can finally take a breath. I start at 6. In other words, my point is 0, 6, because my exact number is always going to be 0. My rise is a -2, and my run is a +1. In other words, I go down by 2, and I go to the right by 1. 1, 2, right. 1, 2, right. 1, 2, right. 1, 2, 1, 2, 1, 2. There we go. If I wanted to draw the other side, let's look at this fraction. What's my rise? Angus, what's my rise for this fraction on the bottom right here? So it's up by 2. What about my run? What does that mean? Good, left one. So if I move to the left one and 2 up, does it fit my pattern? Yeah, left one, 2 up. It fits my pattern. And so Let me connect the dots. Bam. Look at that. So everyone, before I let you go, really think about what we've done for the past week and a bit. We learned about the rate of change. That's how we move on a line. We learned about the initial value. That's my y-intercept. That's the only two things those are the only two things that you need to create an equation. And why do we care about an equation? If you have an equation, you can move and predict anywhere on this line just from a simple calculation. Okay? I'll stop right here. My homework for you today, along with preparing yourself to finish your assignment 2, your Barbie Bungee assignment, part 1 and 2, tomorrow at lunch. Today, I'd like you to go home and see if you can graph these 4 equations on the back of this page. All right? All right.